Welcome to the Explainer. Today we're going to get right into the weeds of Linux memory management. We'll be looking at what happens when your system just runs out of steam, and how this newer tool, Systemd-oomd, is trying to solve a really old problem.
You know the feeling, right? You're in the middle of something important, and your whole system just grinds to a halt. It gets sluggish, maybe totally unresponsive. Well, more often than not, the bad guy in this story is one thing: memory.
Okay, so to really get why this happens, we have to talk about something called memory overcommitment. It's a core part of how Linux works, and honestly, it's kind of a gamble.
So what is memory overcommitment? Well, you can think of Linux as a really optimistic banker. An application comes along and says, hey, I need $1 billion, and Linux says, no problem, here's your line of credit. The trick is, Linux doesn't actually have $1 billion in the vault. It's betting, it's gambling, that the app won't actually try to withdraw all that cash at once. And because of this bet, it can promise that money to a lot more apps, letting you run way more stuff at the same time.
Yeah, and here's a fantastic way to think about it. It's just like an airline overbooking a flight. They sell more tickets than there are seats because they know, statistically, a few people probably won't show up. And when it works, the airline makes more money, the plane is full, everything's efficient. It's great.
But what happens when the gamble doesn't pay off? What happens when every single passenger shows up for that overbooked flight? Well, you've got a problem. Somebody has to get kicked off the plane. And in the world of Linux, when all those apps come to collect on their memory promises, the system hits a crisis point. It needs a plan B.
And that plan B, the traditional solution, is something called the kernel's out-of-memory killer. Yeah, we just call it the OOM Killer for short.
So, if we're sticking with analogies, this guy is the bouncer. But he's not a very proactive bouncer. He's the kind that just stands by the door, sees things getting heated, hears shouting, sees chairs being thrown, and he does nothing. He only steps in when a full-on bar fight has erupted, and his only job is to grab the biggest guy he can find and throw him out into the street to stop the whole place from being wrecked.
So how does he pick who to throw out? It's not totally random. The kernel actually keeps a running tally, a sort of naughtiness score for every process. It's called the OOM score, and it goes from 0 to 1,000. The higher your score, the more likely you are to be the one that gets the axe.
And what gets you a high score? Well, it's pretty simple actually. The number one factor is just how much memory you're using. The more memory you're hogging, the higher your score goes. Now, it's not just that. Important stuff running as root gets a bit of a discount on their score, but at the end of the day, memory usage is king.
Now this is where it gets interesting for system admins, because you're not totally helpless. You can actually put your thumb on the scale. There's this little knob you can turn called OOM score adjust. If you have a supercritical process like your SSH daemon, you can set its score adjustment to -1000, basically telling the OOM killer, hey, never touch this guy. On the flip side, if you have a process that you know is a troublemaker, you can mark it for death by cranking its score way up.
Look, the kernel's OOM killer is an absolutely vital safety net. It's always there, ready to save the day. But it has a fatal flaw. It's reactive. It doesn't prevent the problem, it just cleans up the wreckage afterwards. By the time it kicks in, your system is already in deep trouble. And worse, sometimes it makes the wrong call. It might kill your text editor with that unsaved novel instead of the script that was actually causing the problem.
And that whole problem, that reactive nature, is precisely what led to a totally new approach. Enter Systemd-oomd. So if the kernel OOM killer is our lazy bouncer, Systemd-oomd is the sharp, experienced floor manager. This manager is constantly walking the floor, listening to conversations, and can tell when a situation is about to boil over. Instead of waiting for the fight, they step in early, tap someone on the shoulder, and say, hey buddy, maybe it's time to call it a night, preventing the whole mess from ever happening.
So how does it pull off this magic trick? Well, it uses a couple of really clever modern kernel features. The first one answers the who question. It's called control groups, or C groups for short. This is an awesome feature that lets the system group related processes together. Think of all the different processes that make up your web browser. They can all be put into one C group. This gives Systemd-oomd a single collective target to watch. Okay, so if C groups are the who, the second feature, pressure stall information, or PSI, is the what. This is the real game changer. PSI is basically the kernel's stressometer. It doesn't just tell you when you're out of memory, it tells you how much time your applications are spending stalled, just waiting around for memory to become available. It's a true early warning system. So let's put it all together. Here's the playbook for Systemd-oomd. Step 1. it keeps an eye on the PSI metrics for each of those C groups. Step 2, it checks if that pressure reading goes above a certain danger level and stays there. And if it does, Step 3, boom. It doesn't just kill one process. It sends a kill signal to every single process inside that misbehaving C group.
Now, here's something that might sound a little backward at first. Systemd-oomd actually works better if you have swap space. You'd think swap is just a slow fallback, but for oomd, it's a critical part of the process. When the system starts swapping heavily, it creates a huge amount of memory pressure, which lights up the PSI metrics like a Christmas tree. That's the signal. That delay gives Systemd-oomd the precious seconds it needs to act before the system locks up completely.
Okay, so we've met the two contenders. Let's put them in the ring and do a real head-to-head comparison.
This really breaks it all down, doesn't it? On one side, you have the kernel OOM Killer. It's in kernel space, it's purely reactive, it's a late intervention, and its scope is just one single process. On the other side, you've got Systemd-oomd. It's a user space daemon. It's proactive, acting early, and its scope is the entire control group. The way they make decisions is totally different too. One uses a simple score, the other uses these advanced pressure metrics. The complaints say it all. One is too late and kills the wrong thing, the other can be way too aggressive.
And that core difference, killing a whole group, is a real double-edged sword. People running servers or containers often love it. If one web service starts leaking memory, oomd takes out that entire service, protecting everything else. But on your desktop, that same logic means if one browser tab goes crazy, oomd might just kill your entire browser session. All your tabs, all your windows, gone. You can see why that's a point of contention.
So this brings us to the big question, right? Which one of these is actually the right tool for the job? Which one is best for you?
Well, Systemd-oomd is an absolute rock star in certain environments. We're talking servers, we're talking containerized workloads, any place where you have nicely isolated services and where overall system responsiveness is the #1 priority. In those cases, its ability to surgically remove a misbehaving service before it causes damage is a huge win.
But here's the other side of that coin. For a regular desktop user, it can be really disruptive. Losing your whole session is no fun. And it's not a plug-and-play solution for everyone either. You need a modern kernel with the right features enabled, it works best with swap, and tuning it can get pretty complex. It's definitely not as simple as the old kernel killer.
And this whole debate really leaves us with a bigger, more philosophical question for the future of Linux. Where should this kind of intelligence live? Should the kernel's job be to provide a very simple, very dumb, but very reliable safety net? Or, as our systems get more and more complex, is the real path forward through smarter, more sophisticated user space tools like Systemd-oomd, even if they come with their own set of trade-offs? Something to think about.